Hi, in this lesson, I'll be teaching you about the standard normal curve and the areas associated with z-scores. In the last lesson, I talked about just the normal curve, its characteristics. We talked about the density curve and the areas associated with a given variable. And I started to talk about or touch on how that relates to the standard normal curve and how we can use the standard normal curve to look at things on the same scale. So we're going to dive a little bit farther into the standard normal curve in this lesson. The properties of a standard normal curve are similar to a density curve or just normal curve. The area is still 1. The curve extends indefinitely without ever touching the horizontal axis, so it's kind of like levitating above the axis. The curve is centered about 0, and almost all of the area under the curve lies between -3 and 3. So I talked about this last time in the last video that we're talking about z-scores. When we're talking about a standard normal curve, we're talking about a standardized variable, which means it's in z-score. And for anything to have a z-score past 3 or past -3 would be considered extremely unusual. So that's typically why we are restricted to -3 and 3. If you remember from the empirical rule, 99.7% of your data should lie between -3 and +3. And then it being centered about 0, if z-scores are referring to the number of standard deviations something is from the mean, with the mean being the center, then the mean itself would be 0 standard deviations from itself. So that's why 0 is in the center, and then we go out 1, 2, and 3. To find the area under a standard normal curve, you can use the tables in your textbook or a calculator. You can also, if you don't have a textbook with z-tables in it, which is rare, I would think, you can Google z-tables and look at the images, and there are tons of options for you to see z-scores. The area given represents the area to the left. So when we're talking about a z-table, when we look at the areas on a z-table, those represent to the left. And I think in some older calculators, if you type this into your calculator, it will automatically give you the area to the left. The newer calculators, you can adjust the bounds of the region you want. So yay, technology. But when we talk about area in the textbook, it's to the left. And here's a picture here of just a normal curve. When we have, if we want to make it a standard normal curve, we're saying that 0 is at the center with a standard deviation of 1 in both directions. So a z-score of 1 is 1 standard deviation from the mean. A z-score of 2 is 2 standard deviations above the mean. -2 would be below the mean. So hopefully you remember that. Determine the area under the standard normal curve that lies to the left of 1.25. Since it says standard normal curve, 1.25 is a z-score. And we're looking for the area to the left, which thankfully, that's the area that's given in our tables. One of the things that can really help you visualize what you're looking for is to just sketch a picture. Since I know that 1.25 is a z-score, that means it's 1.25 above the mean. The mean is going to be 0 if it's standardized. And then here's 1, here's 2, 1.25. I'm just sketching it. And then we want the area to the left. So when we find our area, it should be pretty big. Should be a pretty large number. To use a z-table, if you're given the z-score, you can see this little z here. This is referring to the first digits, and this is referring to the last digit. We have a z-score of 1.25. So 1.2, I'm going to use a highlighter here, is right here, and 5 is right here. Now, if we drag our fingers and see where those meet, then that's right here at 0.8944. So the area associated with a z-score of 1.25 is 0.8944. Do we want percent? No, just area. Now remember, this is the area to the left. All of these areas in here are the left. If we needed to find, it didn't ask for this in this problem, but if we needed to find the area to the right, we would do 1 minus 0.8944. So we would still need to find that area associated with 1.25, but since we're looking for the other side, we would have to subtract. Now, yay, we can do this in the calculator, which is wonderful. So it's really pretty simple. It is a normal curve and it's a density curve. So we're using normal CDF in our calculator. And then what you want to tell your calculator is what region you're looking for. If we're talking about the normal curve, what region are we looking for? And if you have not an old calculator, some of the newer ones will let you use infinity, but most calculators don't have an infinity symbol. So it's going to basically want you to use a really small number for negative infinity and a really big number for positive infinity. It doesn't really, you don't have to count the exact zeros there. It just has to be a really big number. And then basically what you're typing in is the left bound, the left bound, the right bound, the mean, and the standard deviation. Since this is a standardized variable, the mean is 0 and the standard deviation is 1. However, your calculator is going to assume it's standardized, so you really don't even have to put that last part, but it's a good habit. In this example, it's asking us for the area that lies to the right of 0.79. You can do this using your table of values, or you can do it using your calculator, but it's still always a good idea to sketch about where that is once to the right. So if we were to use our table, we would have to use the complement to find that. Let's see up here in our table. If we did 0.7, nope, my table's not big enough. I'd have to Google it. Let's do the calculator. So if I were to put the bounds for this, I'm going to use normal CDF. My left bound is 0.79. My right bound goes to infinity with a mean of 0 and a standard deviation of 1. And then we're just going to type that in. So I'm going to bring up my calculator. I'm going to go to vars, second vars, normal CDF, 0.79, comma, a big number, comma, 0, comma, 1. Close the parentheses. And we get about 0.2148 for our area. If you do have a table handy, you could look up the z-score of 0.79, and the area associated with 0.79 is 0.7852. And then to find the area to the right, you do 1 minus 0.7852, and you get 0.2148, which is what we got with the calculator. So yay. Okay, last example here. we've got find the area under the standard normal curve that lies between negative 0.67 and 1.25. I want you to pause it and try this on your own and then come back and check your answer. If you did this in the calculator, then you would need to type second vars, normal CDF, left bound is the smaller number, right bound is the larger number, 0, 1, and you get about 0.6429. Now, if you did this by hand using the tables, you would have to find the area associated with negative 0.67, and then the area associated with 1.25, subtract the two areas, and there's your area. What do these, last question, what do these areas represent? If you'll remember from my previous video, area is associated with the percent of observations that lie within a given region. So up here, we could say 64.29% of the observations lie between negative 0.67 and 1.25. That's all it's asking. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know and I'd be happy to help. See you in the next one.